Hello everyone, here is Haris, and in this video we will perform the static structure analysis on a simple bar. So this basically links with civil engineering, structural engineering and mechanical engineering. For any type of analysis we have basically 6 steps that we have to follow. The first one is we have to specify our material, which kind of material on we have to perform our analysis, and the second one is we have a mesh. We have to create our mesh, and according to the type of mesh we have to perform our boundary conditions, and after the implications of boundary condition we chooses our solutions, and after setting up solutions we have to conclude our results. Either it depend upon the type of analysis we are doing. There are different type of analysis. As you can see here in the analysis system, we have different type of analysis like coupled field static, coupled field transient, design assessment, eigenvalue buckling, electric, explicit dynamic, fluid flow, blow modeling, fluid flow CFX, fluid flow fluent, fluid flow polyflow, harmonic acoustics, harmonic response, hydrodynamic diffractions, IC engine fluents. So all these are links with mechanical, civil and electrical engineering. So in this video we simply apply static structure analysis on our simple beam. So first we have to choose our material. For the selection of material we have to open the engineering data. In our engineering data we have different types of materials that we can choose according to our requirement. So here for predefined, structural steel is selected. So we can easily check all the properties of our material, like here its physical properties, its linear elastic properties, its hyperplastic properties. So we can easily check all its parameters. Like here we can see the density, isotropic elasticity, SN curve, tensile strength, compressive strength, tensile ultimate strength, compressive ultimate strength. So ANSYS predefined as a different types of material we can choose according to our requirements. So we can also choose different materials depending upon our nature, but for structural steel we choose structural steel for the structure analysis. And the next step after choosing the material is to select the mesh, and before mesh we have to choose our geometry. So first we draw our geometry in the design modeler option. So just right click on geometry and then click on the new design modeler geometry, and after some time our design modeler will open and we will draw our geometry in our design modeler. And after the finishing the geometry, then we will apply our mesh on it, and after the completion of mesh we choose our boundary condition. In static structure analysis we basically see how much stress a material can bear as or geometry can bear. So first we have to draw the simple bar. For this I will choose XY plane, and here in sketch option we choose a simple rectangle, and after that, depend upon our geometry or coordinates, we draw a simple bar. So this is simple rectangular bar, and on this bar we will do our structure analysis. And after that we can choose dimensions according to our design requirements. So here I choose random dimensions, so you can choose according to your requirement. After drawing this simple bar, click on the generate option. It will generate it into 2D. So you can see it's a 2D simple bar. For conversion of this 2D simple bar into 3D, we click on here extrude option. So he is asking about on which geometry we have to apply the extrude. So you just have to press Ctrl and click on all the faces of the bar, and then you can also choose how much depth the material goes into a 3D space. So I will choose 3 meter here, and then you just have to apply. And after clicking the apply from here, you have to click on generate, and when you click on generate, so your 3D bar has been created. So this is our bar on which we will perform static structure analysis. So we have basically performed our two steps. The next step is to perform a mesh. So for mesh, we have model. So we have to open our model system where we apply a mesh. We can also apply a mesh on different modules like ANSYS ICEM and different types of meshing software use like convergence and flow, polyflow. We can also do mesh on them, but for simple mesh we can also do on a model platform. So here you can see this is ICEM CFD. So this is basically a big platform for the meshing, for long-term meshing, for different types of meshing. But in this case we have to do a simple mesh. So we create here on a model geometry. So this is the geometry that import in the design modeler mesh section. So for static structure analysis we have to fix the one end, and for this, before getting into this option, we will choose our mesh. So in mesh we have different types of default parameters. We can modify them according to our requirement, like the sizing of mesh, quality of mesh, inflation, and different types of advanced options. So in this tutorial we will simply just generate a mesh. So after solving the backend imports, or processor calculate different types of mathematical modeling at the backend, and after that this mesh created. So you can see in mesh we basically defined the whole control volume into a small patches. You can see here we defined our whole geometry into a small patches. So after mesh, our next step is to perform the setup. Basically we have now we will perform different types of boundary condition on our structure. For that we click on solution, insert, and before insertions of results we have to perform the fixed port at the one end of the bar. So I click here on fixed port. So just press Ctrl and click. So this end will be the fix, and on this end we will apply a force, and on this bar face, this face we will apply a force, and we will check how much stress created and in the implication of our force. So this is our fixed port, and just we have to click apply. After that we have to import our loads. So we click on force, and we just have to select the face where we have to apply a load in Newton. So I will applying the force on these faces. Just we have to click upon these faces, and here it is asking about the magnitude of the force. So I have apply about 50 Newton. He is also asking about direction. So depending upon our requirement we can either choose the left direction, right direction, upward direction, the downward direction. So I can choose only this direction here. So after apply the force we have to include and import our results. In the result option we can conclude different type of deformations, different type of strains, different types of stresses, energy, linearized stress. So first we calculate the total deformation. After that we calculate these equivalent von Mises stresses, and then at the last we conclude stress, how much stress generated at the implication of 50 Newton force. So after defined our solution problems we just have to click on the solve option, and after some time our problem has to be ready, and we will check or what result we have to do and what result we get after the amplification of 50 Newton force. So this is the solver that is solves our problem, and then at that time our problem has been ready. So we just have to click on total deformation. This is basically the deformation it shows as a result of over 50 Newton force when we apply at this end. You can see the bar is roundabout bend after the amplification of force, and when we can also see how much impact happens in this bar. So basically these colors shows the strength of the force deformation. Red color shows the deformation is maximum, and blue color shows that at that region the deformation is minimum. So you can see we just fix this end, and at this end deformation is minimum, and at this end the deformation is maximum. Same like we can see the value of stresses and strains. So you can say here elastic strain at this point, you can see at this point the elastic strain is high, and at this point the elastic strain is low. Same is the condition for the stresses. At the end of this one the value of stress is high, and this end the value of stress is low. So this is our whole analysis that we have performed by using ANSYS. This can be used by using ANSYS software or Abacus software, or you can say there are different analysis software used by mechanical engineers, structural engineers, or civil engineers. So hope you like this video. So kindly like, share and subscribe. Thank you.